The oxyacetylene torch is used to join or weld metal parts together. This is done by melting the adjacent edges of the joint and adding a filler metal. When the molten metal cools, it becomes a solid bond which holds the two pieces of metal together. Different kinds of metal require different welding procedures. This picture will show the welding of light steel tubing. Oxyacetylene welding is extensively used in industry, where steel tubing is used for motor mounts, struts, racks, frames, and other parts. The oxyacetylene welding outfit must be carefully assembled and adjusted. First, be sure to secure the oxygen and acetylene cylinders in position so they cannot fall. Remove the oxygen valve cap and crack the valve, that is, open and close it quickly to blow out dust and dirt. Remove the cap from the acetylene cylinder and crack the valve in the same manner. Don't stand in front of the valves when you open them. Be sure there is no fire present which might ignite the acetylene. Attach the regulators to the cylinders. The attachment nuts on the oxygen and acetylene regulators differ in size, as do the cylinder valve outlets. This prevents improper installation. Tighten the nuts firmly, but do not force them, or the brass threads will be stripped. Attach the hose to the regulators. Acetylene hose is usually red, oxygen green. Either or both may be black. The oxygen hose connection has a right-hand thread, the acetylene hose connection a left-hand thread. Handle the hose carefully to prevent damage. Wrap it around the handles of the cylinder truck to keep it off the floor. The acetylene hose connection is left-hand threaded. This prevents incorrect attachment to the torch. The acetylene hose connection is grooved for easy identification. The oxygen hose connection is right-hand threaded. Tighten the connections firmly, but do not force them. The number of the tips depends on the thickness of the metal to be welded, in this case 1/16 inch. Refer to the welding chart furnished by the manufacturer of the equipment you are using. For this equipment, the chart shows that for 1/16 inch steel, a number 1 tip should be used. Before you insert the tip, wipe off the thread. Dust or dirt on the thread will prevent a tight fit and may cause a leak. Screw the tip firmly in position. If the tip position does not permit easy handling of the torch, loosen the mixer nut, adjust the tip position, and retighten the nut. Refer again to the welding chart provided by the manufacturer of the equipment you are using for the acetylene and oxygen pressures. For 1/16" steel, pressures of 1 pound are used for both acetylene and oxygen, provided the hose length is 25 feet or less. Before opening the oxygen cylinder valve, back off the pressure adjusting screw by turning it to the left. Then open the valve slowly to the full extent. The pressure in the oxygen cylinder is shown on the cylinder pressure gauge. Open the acetylene cylinder valve in the same manner. To adjust the oxygen delivery pressure, open the oxygen valve in the torch. Turn the pressure adjusting screw until 1 pound shows on the gauge. Close the oxygen valve. Set the acetylene delivery pressure the same way, opening the cylinder valve 1 full turn. Never use acetylene pressures over 15 pounds. Turn the acetylene valve a full turn. Use a friction lighter to light the torch. Adjust the acetylene until the flame is in contact with the end of the tip. Open the oxygen valve until the desired flame is secured. For light steel welding, a neutral flame composed of approximately equal volumes of oxygen and acetylene produces the best results. In oxyacetylene welding, filler metal is usually required. In this case, it is provided by the welding rod. Welding rods are selected according to the type and thickness of the metal to be welded. Use the correct type and size for the work you are doing. Until you become familiar with rod selection, it may help you to make a rod table such as this. This shows that a 1/16 ferrous rod should be used for 1/16" steel tubing. These 2 pieces of 1-inch steel tubing are to be butt welded. The edges to be welded have been smoothed and cleaned so that all traces of oil, grease, dirt, and foreign matter are removed. Use a V-block to hold the tubing in alignment. Light and adjust the flame. Tack weld the tubes in position. Allow about 1/16 inch between the tubes for expansion. Tack weld the tubes at 3 points. Since this butt weld is to be made without moving the tubing, a special stand is used to hold the tubing in position. Bend the welding rod so it can be easily used. Start the weld at the lowest point on the tubing. Hold the tip of the flame cone about 1/16 of an inch from the metal. pointing the torch straight ahead at an angle of about 45 degrees. When the metal becomes molten and forms a puddle, apply the end of the rod to the front edge of the puddle. As the rod melts, slowly move the torch tip forward, positioning the torch so the correct flame angle is maintained. In this type of weld, the most difficult point is the underside of the tubing, because the metal tends to fall away from the weld if the applied heat is too great. Heat carefully and don't permit the metal to become thin. When the weld is stopped for any reason, start again by making the metal thoroughly molten. Then add the rod and advance the puddle. Stop the weld when the top of the tubing is reached. Heating the metal surrounding the weld when the weld is stopped helps to reduce uneven contraction and buckling as the metal cools. Weld the other side of the joint in the same manner, starting at the extreme bottom and working towards the top. Remember to maintain a uniform speed of forward movement and a uniform rod addition. Deposit the metal evenly at the point where the two welds meet, so the evenness of the weld is continuous. Notice how even this weld is, with a uniform width and height. This indicates that the weld was properly made and is the result of using a constant welding speed and maintaining a continuous rod flow. The inside of the tubing also shows a good weld. There is no excess penetration and no metal drip. A T-weld is made in a somewhat different manner. In preparing the tubing for this weld, the upright piece must be ground to fit the contour of the horizontal piece. A good fit is essential for a good weld. Adjust the goggles, light the torch, and adjust the flame. Tack weld the tubing at the 2 points where the top of the horizontal tubing touches the vertical tubing. Start the weld at the high point on the horizontal tubing. When the metal becomes molten, apply the rod and advance the puddle at a uniform speed. In making a T-weld, it is usually best to do what is known as quarter welding. That is, make the weld in 4 sections. Run the first weld to the low point on the saddle. Stop the weld when the low point is reached. Adjust the position of the tubing for convenient operation and continue the weld. The most difficult part of this weld is the low point on the saddle. Here the metal on the upright piece is thin and can be easily burned unless the flame is kept constantly in motion. Careful control of heat and speed is important at this point. Stop the weld again when the high point is reached. Adjust the tubing position for continuation of the weld. Run the weld down to the low point on the other side. Then complete the last quarter by running the weld up to the starting point. The finished weld, when correctly made, has a uniform, even appearance. The tubing holds the heat and can cause a painful burn unless handled carefully. This has every appearance of a good weld. The radius is uniform and has been well maintained. The weld has a constant width, and there are no high spots or low spots. A good welder takes care of his equipment. When you have finished for the day, turn off the oxygen and acetylene, drain the hose and release the adjusting screws, and disassemble the torch. Remove the hose and regulators. Leave everything in good condition and in its proper place for the next operator. Now let's review some of the more important things to remember in simple tube welding. Assemble the welding outfit carefully. Refer to the pressure chart and rod table to determine acetylene and oxygen pressures, size tip, and size rod to use. Adjust the acetylene and oxygen until a neutral flame is produced. Thoroughly melt the metal before starting the weld. Add the rod at the far edge of the puddle and maintain a continuous flow. Move the flame at a constant speed and hold the correct flame angle for the work you are doing. Care and practice leads to good welding.